Okay, guys, we're going to do one last video for 4.C, and this is where we're actually going to be creating the graph based on the function that they give us. So this is kind of a little synopsis in this box about how we do this. We are trying to find ordered pair solutions for the equation that they give us. This can be done a number of different ways, and as we get a little bit more into algebra, you'll see how we do this. But today, we're going to just basically create an input-output table. We're going to create a table of values. And then we're going to graph the ordered pairs, and we're going to see if we can determine the shape of the graph. If we can't easily see what the shape of the graph is by our ordered pairs that we've picked, we've got to go back and pick some more. So we're going to connect the points and extend the graph to the end of the grid and draw arrows to indicate that it goes on forever if, in fact, our particular function, our particular equation can do this. And it says some real-world functions will have variables that are only positive or only negative, depending on the situation of the word problem. In science, you really only deal with first quadrant most of the time. All your variables, all your x's and your y's, your independent and dependent variables are mostly always just positive. So let's look at an example. You can pick any point you want for x. You're the master of your own ship here. You're creating your own table. You're going to pick a value for x. You're going to substitute it in, and then you're going to see what your output, your y, is going to be. I almost always start with 0. 0 is a nice, easy number to plug in. It usually makes my answer pretty small. So 2 times 0 minus 3 is going to be negative 3. So my ordered pair is going to end up being 0 as the input and negative 3 as the output. Generally, I'll do a couple positive and a couple negative. So let's just pick one to keep our numbers kind of small. Go back to your original equation. 2 times 1 minus 3, which is 2, minus 3, which is minus 1. So when the input is 1, the output is negative 1. I'll go on the other side and pick a negative 1. So now we're going to plug in negative 1, and we get minus 2 minus 3, which is minus 5. So when the input is negative 1, the output is 5. Maybe I'll pick one more lying outside a little bit more, positive 5. So 2 times positive 5 minus 3, 10 minus 3, which is 7. So when our input is 5, our output is 7. So generally when I have 4 points or so, I'll go ahead and plot them and see if I can see a pattern. So when we plot 0, 3, we start here and we go down 1, 2, 3. That point right there takes care of that one. 1, negative 1, so positive 1, negative 1, right there. Looks pretty good. Negative 1, positive 5. Oh, it's negative 5. I knew that was wrong. Negative 1, negative 5. 1, 2, 3, 4. There he is. I'll just cover him up. Negative 5. And then our last point is positive 5 over here and up 7. So there's 5 and 2 more make 7. So if you look at this, and if you were to lay a straight edge across here, I think you can see that we're going to come up with a straight line. If you're doubtful, go pick another point in here and see if it lines up and makes a straight line. But in fact it does, and I'm terrible at drawing straight lines without a ruler, and I don't know if I can actually do this very well. I can't. But it is a straight line, and that's what the graph would look like. So I suggest that you get a ruler or a straight edge so that yours will look a little bit better than mine. Okay, let's skip to example C on the next page. It's a little bit different looking. Example B, I think you can do on your own. Example C has an absolute value in it, but that's okay. We're going to do the same exact thing. We're going to pick our x's, and we're going to plug them in and get the output value. So if I pick 0, because I usually do start with 0, we get the absolute value of 0 minus 2. So that is 0 minus 2, which is minus 2. So our ordered pair is 0 minus 2. If I pick a positive 1, I get the absolute value of 1 minus 2. So that is negative 1. Then I'll pick a 2, perhaps. Absolute value of 2 is 2, minus 2 is 0. And now I'm going to go over to the negatives, and I'm going to go negative 1. So the absolute value of negative 1 minus 2 ends up being the exact same thing as the absolute value of positive 1, because it comes out as a positive 1. So our ordered pair is negative 1, 1. And if you try negative 2, I think you'll see the same thing happens. Absolute value of negative 2 is positive 2, which is what we had up here. Minus 2 is 0. Let's pick one a little bit further down, a pair. Let's pick a positive and a negative. Positive 5, absolute value of 5, minus 2, which is 3. And let's do his negative partner, absolute value of negative 5, minus 2 is also 3. So when we go over here to plot them, when we plot the first couple, we get 0, minus 2. Okay, here he is. 1, 2, there he is. 1, negative 1, right there. And we get 2, 0. So pretty much this looks like, if these were the only 3 points we plotted, we'd think this was a straight line. And rightfully so, because it looks like a straight line. But it's not. Because when you plot the next points, you get negative 1, positive, you get negative 1, that should be negative 1, right? Negative 1, negative 1. You get negative 2, 0. When we come over to the 5, we get 5, 1, 2, 3. And we get negative 5, 1, 2, 3. So this is actually making a V, if you can see it. It makes a V. Again, I cannot do this. This is like embarrassing, but I don't have a straight edge on the software. So every absolute value function, its graph is a V. So you have to pick enough points on an absolute value function to find your vertex, the bottom of your V, and figure out how far it goes out in the width. So that's an interesting, an interesting graph that you might have not done before. So thanks for watching. See you next time.